2024 ADMA paper 1 question 5. So every time you have a question like this, change your mode to radians, because everything that has to do with this question will always be in radians, unless they have decided to change and use degrees, which of course will be required to convert to radians. So in the diagram, OAC is a sector of a circle, center O and radius 5 centimeters. AF is equal to CD, which is equal to 2 centimeters. DE is equal to EF, which is equal to 2 centimeters as well. Actually, one of them should be 3. Oh no, it's okay. And OB intersects DF at E at 90 degrees at E. Find the value of theta in radians. So depending on what you see first, you have a lot of choices here. This is the same as this, so this is 3, this is 3. Then from here to there you have a 2 here and a 2 there, so that makes this one a 4. So to find this angle, you can just use the cosine rule, or depending on what you see first, of course, you can simply use this by finding half of the angle. So I've just extracted this smaller triangle. So you have the right angle here, the hypotenuse, and the opposite. So that means you can simply use sine to find this angle. Since this is a lot of work for me, I'll use sine and then double it up. Remember, we have 2 of these. So we have another 3 here and another 2 there. So we have half theta here and half theta there. So you can say sine half theta, remember this is just half of theta, is equal to the opposite, which is 2, over the hypotenuse, which is 3. Then this will be half theta is equal to sine inverse of 2 over 3. So you have half theta is equal to, so let's find sine inverse of 2 divided by 3. This is 0.7297. so now when you multiply both sides by 2, you have theta is equal to this thing times 2. This will be 1.4595. Actually, this one will be a 4. And then when you round it off correct to 3 decimal places, this will be 3 significant figures. This will be 1.46 radians, and you have found your theta. If you want, you can just find half of it without putting a half there. So you get this and then multiply it by 2 to make it up for the other part. So our theta is equal to 1.46 radians. So for radians, you can either say rads or don't put anything at all, or even the word in full. And then the length of arc AC. So to find the length of the arc AC, you can use this formula. Arc length is equal to r theta. So AC is equal to r is the radius of the sector, which is the distance from here to there. So that will be this one plus this. So 5 multiplied by theta. Our theta here is this thing, which we have just found as 1.4594. So I'll use this version as opposed to the rounded off one. Yes, even this one is rounded off, but it's more accurate than the one we got. So now let's multiply these two numbers. 5 multiplied by 1.4594. So this is giving us 7.297, which is 7.30 centimeters when you round it off. Remember, this is length, so it's just the unit will be centimeters, just like that. So this solves the entire question.